But now I want to explain in atomic structure about two different models. One is J.J. Thomson. Next, after that, Rutherford alpha particle scattering experiment. In J.J. Thomson, how he did the experiment, he got the Nobel Prize also. What he has says in J.J. Thomson experiment, the atom is completely spread with a sphere of positive charge, like this. The atom is completely sphere with a positive charge. The electrons are embedded like this. If you take ghee, like badam and pista, like that, in ghee we put a badam pista like that, the electrons are embedded like this. What he has observed, one is, it is sphere of positive charge. The atom is completely sphere of positive charge. Second one is this model is called as a plum pudding model, because the negative charge is pudding like this, and also watermelon model. In like watermelon, this positive charge is red color, this electrons negative charge is seeds, like that. Third one is, it is a sphere of positive charge complete. It is plum pudding model or watermelon model. If you take but atom is electrically neutral. One more here says the atom is electrically neutral. He says these are the 3 points he has discussed. J.J. Thomson, he got for doing this experiment, he got the Nobel Prize also. What he says, one is, it is sphere of positive charge, and also it is a, this positive charge is like a ghee in the badam or pista, like that, the electrons are embedded in the atom. This model is called plum pudding model or watermelon model, like that. Atom is electrically neutral because positive or negative equal. It is a sphere of positive charge. For doing this experiment, J.J. Thomson has got the Nobel Prize. After that, one of the most important scientist, that is Ernest Rutherford. Ernest is colleague of Rutherford. He did the experiment. He is explain about the radioactive elements, like that. A radioactive experiment. He got the amount from did it. Next, first, what is Rutherford experiment? Ernest Rutherford. His colleagues has done and reported to him regarding about the stability of the atoms, and also how the atoms are exist, how the positive charge exists in the atom, like that. What he has did, he has taken the alpha particle. What is alpha particle? Alpha particle means plus 2 helium. Helium plus 2 charge is called alpha particle. Alpha particle. Helium plus 2 charge is called alpha particle. Helium is heavy mass. It is having 2 protons plus 2 neutrons, and 2 electrons are surrounded it. That is called helium. Helium is atom is like this. 4, 2. If we remove these 2 electrons, by removing these 2 electrons, it is plus 2 charge. 4 mass is 2 protons and 2 neutrons. This is heavy nucleus. This is called alpha particle. This helium plus 2 charge is called as a alpha particle. Proton having positive charge. By taking this alpha particle, we bombarded with any metal atom, then it will go. It will allows the alpha particles to reflect in the screen. If you take for example any source of radioactive element passes, if you put any metal, or if you take gold, thin gold foil metal, if you put a screen here, zinc sulfide screen, by passing the alpha rays, alpha particle through this gold foil, most of the alpha particle is hit to this. Some of the alpha particle is by small deviation they will go to this one. Out of this, one of the alpha particle reflect back. Reflect back. This is source of alpha particle. Any radioactive element, by taking any radioactive element, we did the experiment, radioactive experiment. This is the experiment. By doing this experiment, Rutherford has observed what he has observed. One of the important point is what he has observed. Most of the alpha particles pass through this atom. Most of the alpha particles pass through the gold foil. Second, he has observed some of the alpha particles deviated with small angles. Third, he is observed, one is out of the 20,000, one of the alpha particle reflected back with a large angle, like that 180 degrees is reflected back. By observation of these three, what he has noted means the atom is, most of the atom is empty, hollow. In case of J.J. Thomson, what he has said, J.J. Thomson, the atom is completely sphere of the positive charge. If it is positive charge, alpha particle, it will not allow the atom. It will completely reflect it back, because positive is repulsions are there. That's why this is, but it is contradictory to the J.J. Thomson model. He says he has observed most of the atom is empty, hollow. That's why then most of the alpha particle passes through this gold foil. One of the most important observation of this, if most of the particle is allowed, one of the particle is reflected back with 180 degrees, means it is having one of the center, it is having one of the atom is having center, that is called as a nucleus. Then we call it as a nucleus. This nucleus is having heavy mass, heavy atom. Then only it will reflect back that alpha particle. Next, then only it will reflect back the mass of the atom is 10 to the power of times of mass of the nucleus. Because if you take in the cricket ball is the nucleus, then its ground is the entire mass of the atom. He has observed these observations. Rutherford has successfully did the experiment. Before that, nobody has find out what he has observations. You write it here. What he has observed. He has discovered the nucleus. Before that, nobody will discover. He has discovery of the nucleus. That is Rutherford model. He has discovered the nucleus. What he has observed by doing alpha particle experiment, most of the part of the atom is hollow. Hollow means empty. Most of the atom is empty. The positive charge of the atom is very small space. Positive charge of the atom occupies very small space. Most of the part of the atom is hollow and positive charge of the atom is heavy. This positive charge is heavy. This positive charge is heavy. This is positive charge is heavy. There is something very heavy in atom. This is called as a nucleus. Yes, find out nucleus. Next to number of protons is equal to the number of electrons. That's why this is charge is neutral atom. That's why it is neutral atom. The size of the atom is 10 to the power of times more compared to nucleus, because size of the atom is 10 power minus 10 meters. The nucleus is 10 power minus 15 meter. He has observed these are the five observations he has did. The Rutherford he has did the experiment, he has also named it the discovery of the nucleus. He has observed these 5 points. Most of the atoms is hollow because the alpha particle passes through the gold foil and heated the observer scale. He has observed one more thing is, out of the 20,000 only one of the particle is returned back with 180 degrees, means there is something else there at the center, that is called as a with heavy mass, heavy charge, that is positive charge. That's why they will reflect it back to the alpha particle. If it is electrically neutral, because number of protons is equal to the number of electrons, neutral atom. Size of the atom is heavy compared to size of the nucleus, because it is occupies small space with heavy charge, heavy positive charge. These are the 5 observations he has did the Rutherford. He has noted this 5 observations. This is very important. And also he has what he has failure, because what he has explained, he cannot explain the failures of the Rutherford. One is stability of the atom. He cannot explain the stability of the atom. Why? Because he has observed the electron is revolving around the electron revolves around the circular orbit. Electrons revolve around the circular orbit. If you take this, if it is positive charge, if the electron revolves around this nucleus, if it is nucleus, it is having velocity. If electrons revolve, it changes the velocity. Change of the electricity means it is acceleration. Change in electrons means it is having force. This force is called as having force. According to Maxwell theory, what he says, any moving charged particle having it loses energy, it emits radiation, and it loses the energy. It loses the energy, it will immediately, by losing energy like this, it will collapse. That's why the stability of the atom, you cannot explain the Rutherford. One of the main. Second observation he has, what is it? He cannot explain the line spectrum. line spectrum or discrete spectrum. We cannot explain the line spectrum or discrete spectrum. What is line spectrum? I will explain. If you take any vessel, if you put in hydrogen gas, by passing the light, white light, it observe the spectrum. If any light passes to the prism, it will reflect the 7 colors. If you take light passes to the hydrogen gas, you observe violet, yellow. But remaining VBGR 7 colors, remaining 4 colors are missing. These are missing. By changing helium, we observe red, but remaining these 5 colors are missing. This cannot explain the spectrum. You know, electromagnetic radiation, some of the invisible also. But these missing radiations cannot explain this Rutherford experiment. That's why this is having two failures. One is stability of the atom is cannot explain, because any charged moving particle, according to Maxwell, it emits the radiation emits the radiation, it will loses the energy completely. After some of the time it will collapse in the nucleus. One more thing is it cannot explain the line spectrum. Some of the spectrums, by passing light to the hydrogen or helium, some of the lights are missing, spectrum lights are missing. Only these cannot explain the Rutherford. Next, after that came Bose. Thank you.